What's up everyone, Laconde Mwila here, back with another video, and we're talking cloud and K8s. Some of you might be thinking, alright Luke, you got my attention. You used the buzzwords, so what's this all about? And the temptation is to jump right into talking about cool tech, Rancher in this case, and maybe even a demo, but the video is going to be a little bit different, so stay with me. Multi-cloud strategies are becoming increasingly popular, and so is Kubernetes. Now, as you would imagine, more and more companies will want to adopt these models. So I'm going to talk about multi-cloud, its pros and cons, and how the use of Kubernetes can complement such a strategy, primarily because of its qualities as a container orchestration platform. Lastly, I'll speak about how Rancher can provide enablement for multi-cloud Kubernetes. Just so it's clear, K8s is not the only way to do a multi-cloud model, but I will elaborate on how its design puts it in a unique position for this approach. Let's start off with talking about multi-cloud. And this is an interesting topic because there are different definitions and schools of thought out there, but we're not going to get lost in all of those things. I'm just going to go with the basic idea of wanting to operate or have an architecture that is distributed across different cloud environments, be it AWS, GCP, Azure, you name it. Now the question you have to ask is, why would you even bother with such a model? Because one cloud environment gives you operational agility on demand, regardless of the vendor you go with. What makes someone be the kid in a candy store to pick from the AWS section and the Azure section? And I think there are a couple of driving factors behind that. One of those factors is regions. So I'm in South Africa, but for the longest time, I just spun up resources in Ireland or Frankfurt for private projects as well as company projects. And the reason behind this was network latency purposes. But you don't want to be restricted to a specific region or regions, so using multiple clouds can increase your reach to better service certain client requests or improve performance or run certain workloads. And in some cases, certain cloud service offerings aren't available in certain regions, but you might find another cloud provider has a similar service in the specific region that you actually want. So spreading it across cloud providers would help. The next one is actual cloud compute services. And there are different ones for different requirements, but most cloud providers offer similar solutions. And maybe you want to have the freedom to choose between S3 or Google's cloud storage based on what will best serve your application or solution, as opposed to being locked into a specific cloud and then making a choice from there. Next is cost optimization. Companies and teams want to have the freedom to choose, mix and match between different services from different cloud providers based on their pricing. Last but not least, vendor lock-in. And I don't have to say much here because in my experience, it's the most popular reason for multi-cloud. Not that it should be, but people want to have the operational agility, portability, and costs of running their applications to go beyond just one cloud provider. Now, this might sound all nice and dandy, but it's a lot harder in practice for a couple of reasons. For starters, complexity. And complexity is subjective, but for large-scale projects at an enterprise level, the landscape of your architecture has more pieces for you to worry about, and they're within different networks and different cloud environments. And next up is cloud skills. Now, there's a huge demand for tech people because of a serious skills shortage. I'm not sure if that's just in the African context, but it's hard enough to find someone with enterprise-grade skills for a single cloud vendor. And I'm not talking about someone saying, hey, I can spin up a Lambda function. I mean people who can design, plan, architect, or build complex systems in the cloud. So if you intend to do this across multiple clouds, you better have a plan on how to get talent, keep talent, and upskill people. Third is cost consolidation. Now, the idea of picking cheaper services from different clouds sounds nice, but you still have to think about how you're going to reconcile, review, audit, and trace costs across different cloud platforms. Even if you federate this responsibility to different teams, they still have to be held accountable. So you need to think about models and tools that can support you with this. Next up is monitoring. And monitoring allows you to keep a close eye on various key things, like your resource consumption, workload and network performance, system errors that may crop up, as well as any other important metrics, logs, or flows in your system. And doing this across multiple clouds can be challenging, but it is vital to avoid various issues from inefficient use of resources to any hidden costs that may crop up and shoot your bills through the roof. And last but not least is security. And this is a huge topic, and there are different vectors that you have to consider based on the potential points of attack. But you need to have a proper system in place for your users to authenticate with the least privilege approach to access control, says the guy who often uses admin access to speed things up. But that's not the point. Your workloads should have the right permissions attached to them to integrate with other services, and of course, there's managing network traffic. And this will look different depending on the use case, whether it's using multiple virtual private clouds and peering them, or mixing the use of private and public networks, or keeping network flow completely private in the cloud. Again, it's challenging enough to do this for workloads in one cloud environment, but you have to apply these best practices and propagate them to different cloud environments. So does Kubernetes solve all the multi-cloud problems out there? Sadly not. But it does have certain qualities that allow it to complement a multi-cloud model. For starters, by design, it's infrastructure agnostic. And that means the Kubernetes you get, whether you're running it on your local machine with Rancher Desktop, Minikube, or Docker Desktop, it's still Kubernetes in the cloud, whether you use Amazon's EKS, Microsoft's AKS, or Google Cloud's GKE. And that's a big deal because it provides a strong layer of consistency when configuring your clusters. So you can declare your configurations for a GKE cluster and they'll work the same way in a Kubernetes cluster in AWS or Azure, provided that you don't have a ton of cloud-specific integrations. For example, Amazon EKS has a feature of using security groups to control traffic at a pod level. Now, Kubernetes network policies do the exact same thing. So if you want the consistency and portability across clouds, rather use network policies. And that brings me to the next point, workload portability, which builds off infrastructure agnosticism. Now, the workload declarations for Kubernetes don't have to change for your clusters across clouds. Just be mindful of your Kubernetes versions and support for the APIs that you want to make use of. But generally, you build out your raw manifests, Helm charts, or customized resources once and deploy away. And I have a separate video demonstrating a GitOps pipeline that deploys to an EKS and an AKS cluster with the exact same source repo, and it contains a pod and a service example. The result? The application worked the same way in two different cloud environments. Thirdly is workflow portability. Now, because Kubernetes is infrastructure agnostic and workloads are configured the same way, regardless of where they run, the teams building out these resources don't have to upskill or modify workload definitions to suit a specific cloud environment. As Nigel Poulton likes to say, Kubernetes is Kubernetes is Kubernetes. In the case of moving workloads from AWS Lambda to Google Cloud's functions, the program business logic remains the same, but there are lots of other pieces that need to be tweaked. Whereas in K8s, you can literally build out the definitions once and deploy to a cluster in the cloud. Is it really that simple? Never is. Managing a single Kubernetes cluster has a lot of intricacies. And if you're planning on doing this at scale in different cloud environments, then you need to consider how you're going to have a thread of consistency for the full lifecycle management of your Kubernetes clusters. And that's where Rancher comes in. So you can have a centralized and consistent approach to managing GKE, EKS, AKS, or other upstream versions of Kubernetes in different cloud environments. As a platform, it's designed to make the cluster management experience simple without compromising on having the features that operators need to do their jobs. How does it specifically address some of the issues that I mentioned when it comes to multi-cloud? Well, operators can focus on Kubernetes and Rancher without them having to juggle being cloud experts and logging into different consoles or dealing with multiple APIs. Basically, everything goes through Rancher, which helps the overall workflow experience for your operators and engineers, instead of them doing too much context switching. And also, they can use Rancher to install monitoring stacks for visibility of the different clusters, as well as manage GitOps deployments to the different downstream clusters for the different workloads, which provides a lot of benefits when it comes to consistency and alignment, especially from a configuration perspective for those different workloads. From a security perspective, the authentication and authorization runs through a single gatekeeper in Rancher that handles the access control of all of the operations for your downstream clusters. Now, I know that was a lot, but I hope you were able to get some value considering all the different factors at play when it comes to managing multiple Kubernetes clusters in different cloud environments. If it was helpful, hit the like button, subscribe to the channel, and stay tuned for more.